Alright, in this video I will be going over the Unit 7 study guide. Unit 7 was all about differential equations, and just generally in this topic it was pretty short, but the topics that were the main points were separation of variables, slope fields, Euler's method, and then other applications of differential equations. But one thing that was very common in this topic was, in this unit was, dealing with exponential functions. And natural log function, using natural log within that too sometimes. And so I included a section about that as well. This first box right here is probably the most, I think, the highest expected thing that I would see on the test is separation of variables. So with separation of variables, what your goal is you're trying to figure out what is the original equation for y. And you're given the differential equation, which involves the derivative, dy over dx or dy over dt for this example that I've put here. So I wrote down the steps here for how you would do separation of variables to solve for y. And so the reason I put this particular equation here is this one is the most common kind that will show up on your on the AP test, that has shown up on the AP test in the past. So this equation right here, the way we would go about solving it is the first step, we want to separate our terms, move the y variables to one side and move the x or the t variables or whatever other variable it is, move it to the other side. So we just want to separate things. So I see I have y on this side. This k is a constant, some number. And then I have dy over dt here. I can separate dy and dt, so I'm going to move dt over here. I'm going to divide y and move it over here. So I should end up in my next step getting 1 over y dy is equal to k times dt. So essentially y and dt switch spots. The next thing we want to do is, once we've separated those variables, is we want to integrate both sides. And when I integrate, we don't want to forget about that constant plus c. When I integrate 1 over y, that's a natural log of absolute value bars y equals, and then the antiderivative of a constant is going to be that constant times the variable. For example, if I had a 2 as the constant and I'm integrating it, the antiderivative would be 2x, or in this case 2 times t, because t is the variable. So here I'm just going to leave k as a constant times t plus c. That's the antiderivative of both sides. Natural log of y, kt plus c on the right side. And then the next step is I would have to evaluate an initial condition. So for example, if a fear response problem gives you a coordinate that the original equation goes through, the original graph goes through, you could plug in the y value here and the x or the t value there, and then you can solve for c. And then you can continue after that to solve for y. So I'll leave this one in terms of c, and I'll just solve for y here. So if I want to get rid of the natural log, I have to apply an e to both sides. So e to the natural log of y is just y, and then e to this entire side, kt plus c. And I can take it a step further and use my exponential rules to simplify e to the power of kt plus c. If you ever have a sum in your exponent, then you can apply the base to both of the terms that are being added up. So e to the kt multiplied by e to the c. So the reason I did that was because e to the c is going to be another constant value again, because c was already a number. So e to the c is going to be another constant number again. So I could just leave this as y equals, I'll introduce a new letter to represent another constant, a, instead of e to the c. A times e to the kt. And this is your most simplified version of this solution right here. And on the AP test, this one shows up very often. Okay, and this is called a proportional exponential growth or decay. So this example goes directly in hand with this next box right below it, where it says proportional exponential growth and decay. So the general differential equation is dy over dt is equal to k times y. That's the equation that I started up with at the top of the first box. And on the AP test, you don't really need to show like how you solved for this. You can just jump straight to its solution. Its solution is always going to be y equals some constant a times e to the kt. Okay, and all you're left to do is figure out what that constant a is. You'll know what k is because it'll give it to you in the problem, and t is just the other variable. So you'll be able to solve for a using a coordinate. So that's all that's going to be in this box right here. Okay. In this box right here, I just put general stuff about e and natural log that people tend to forget. E to the natural log of x is just x. And natural log of e to the x is just x. E and natural log are inverses of each other. So if you ever get an equation that has natural log in it and you want to get rid of the natural log, apply an e to it as a base, and that way you'll just end up with whatever was inside of the natural log. Okay, so that's what I did over here. I did e to the natural log of y, which gave me a y right here. And then there's some other properties of e and natural log here. Natural log of 1 is always 0. Natural log of e is always 1. And then if you would like to, I know you'll have your calculator with you on the day of the test, but if you just want to sketch the graphs real quick, e always looks like it's above the x-axis, and it looks like the beginning of a cursive E. That's how I remember it. And natural log is the inverse, so you just reflect that. Down there, like that. So there's E in natural log. And this coordinate right here is 0, 1. This coordinate down here is 1, 0. Okay, just so you know where exactly that's intersecting the x and the y-axis. Okay, here's the 3 steps. I wasn't really sure what I could put concisely for slope fields. I'm not sure whether or not it will show up, but here's how slope fields work. You can read through those steps about how you identify or create a slope field. And then at the bottom, these 2 topics are BC only topics. So if you, once again, if you're taking the AB test, you don't need to worry about these 2 down here, Euler's method and logistical growth model. Okay, these are for BC only. For Euler's method, the goal is you're trying to use one coordinate and a slope to get to another coordinate or approximately another coordinate on the graph of the original function, and you're using multiple of these points to figure out where a future coordinate is going to be. And the way we used it, Euler's method, is you use the point slope formula. So where does this guy come from right here? It comes from y minus y1 equals m times x minus x1. Okay, m is dy dx. X minus x1 is x new minus x old. And y is y new, and y1 is being added to this other side as y old. So that's where this formula comes from right here. It all comes from the point slope formula. So I'll erase that. And what you're doing is you'll always be given a coordinate to start off with, and you'll be given the slopes or the slope equation to figure out what the slopes would be at each coordinate. You'll have this first row. You'll use that first row, plug into all of this information here, all these terms right here. You'll solve that out and you'll get the next y coordinate, so that can give you the next row, and you keep going through the rows until you get to the coordinate that the problem is asking you to find. And I'll work a particular free response problem just so you can see that in the context. Okay, the last box down here is the logistical growth model. This is also a BC only topic. The logistical growth model is an equation, differential equation that looks like this. ky times 1 minus y over L. And L is what we call the carrying capacity. This is a common application of differential equations in the real world. The carrying capacity is whatever this number is down here. Okay, if your equation is given to you and it looks kind of like this, but this is a little bit different, you have to make it look like this: y over L, the variable y, or whatever the variable is, divided by some value. This value is your carrying capacity. K is just some constant number. And on the graph, the original function y equals this guy right here, these two go hand in hand. This is the original function. This is the slope equation. The carrying capacity is a horizontal line right here. And that's represented by whatever value L is. And the way this graph looks is it starts off flat, increases exponentially, and then levels off. The carrying capacity usually has to do with population of some species, or bacteria that's growing, something like that. And the carrying capacity is the threshold that that environment can hold at most. So this is the logistical growth model, and L is the carrying capacity. It's associated with whatever this value is here, or whatever this guy is down in this denominator right here. Okay, I will work particular skills in free response problems and link them in this section on my website. So be on the lookout for that. If you have any questions, please email me.